In this video, we will learn about linear equations and also how to solve them. First, let's start with the definition of a linear equation. The definition of an equation, a linear equation that is ax plus b is equal to 0, where a and b are real numbers, but a cannot be equal to 0. If a was equal to 0, it would no longer be a linear equation. It would just simply be a constant b equal to 0, and we would not have a variable. The solutions of a linear equation are the values of the variable that result in a true equation. There is a special circumstance that could happen where all values of the variable, in other words, all real numbers, are solutions. Every real number that exists can be a solution to the equation. We call that an identity. So an identity equation is an equation that is true for all values of the variable. To solve a linear equation, I like to break it down into 3 steps, and these 3 steps can be pretty broad, and you might have to do a lot of different things in these 3 steps. But the first part, or the first strategy that you should do, is to simplify both sides of the equation. So when I say both sides, I mean each side of the equal sign, and that can include but is not limited to combining like terms, the distributive property, maybe even canceling out a denominator, things like that. The second part, or the second step in our strategy, is to add or subtract the same, and this is kind of a big deal, it has to be the same expression to both sides. And if you don't add or subtract the exact same expression to both sides, then you have a different equation. You've changed the equation. What your answer would have been is now going to be different. Also, you must, when you add and subtract the expression on both sides, you need to add and subtract it to the like terms of each side. The final step, number 3, is to multiply or divide. The same expression to both sides. Think of an equation as a balance scale, something you might have used in science class. And if that's the case, then we need to continue to make sure that the scale is completely balanced and the same on both sides. If you don't do the same thing on both sides, then you've then changed the scale and it's imbalanced and essentially changed the equation. We now have 4 problems we should try to solve. The first problem is we need to simplify both sides of the equal sign, so we will distribute that quantity or that scalar value of 2 and that scalar value of 3 to both sides, which will result in 6 plus 4x is equal to 3x minus 12. From there, we're going to go to step number 2, which is to add and subtract like terms to both sides. Again, making sure that we're adding and subtracting the same expression. I see here that I have a 4x and a 3x. Those are like terms on opposite sides of the equal sign, so I will subtract a 3x to both sides. At the same time, and I feel I can do this at the same time, I'm going to subtract the 6 to both sides. Now, I did that strategically. I wanted the constant term to cancel out on one side and I wanted the variable term to cancel out on the opposite side, so that the resulting equation is now simply x is equal to negative 18. So in other words, I have all my variable terms on one side and all my constants on the other side. In this case, I don't have to divide because our goal is to get 1x, and we have 1x, so we are done. I highly recommend that you check your answer by substituting it back into the original equation, and when you get a true equation as a result, then you know that your answer is correct. So for example, we have 2 times 3 plus 2 times negative 18 is equal to 3 times negative 18 minus 4. We then have 2 times 3 plus negative 36 is equal to 3 times negative 22. 2 times negative 33 is equal to negative 66. And we know 2 times negative 33 is negative 66. So this does, in fact, check. Number 2, you'll notice that the denominator is now the variable is in the denominator. So that changes this process a little bit. What I would like to do, there's a couple different ways. We can actually add the rational expression, so we can combine the 1/2 and the 2 over x and do some cross multiplication. I'm going to show you a slightly different way. I will look at and think of what is my common denominator of all the denominators. So if you think about all the denominators, the common denominator is actually 4x. So if you want to remember how to do that, go back to simplifying rational, adding and subtracting rational expressions, which is in chapter R. So from here, we have 1/2, 2 over x, and 3 over 4 that we're multiplying by 4x, which becomes 4x over 2 plus 8x over x, and that equals 12x over 4. We can then notice here we can reduce this. So 4x over 2 is actually 2x. 8x over x is really just 8, and 12x over 4 is really 3x. From here, we can go ahead and solve the equation. I'm going to subtract 2x to both sides, and so I have 8 is equal to 1x, which is, in fact, our solution. I will do number 3 in a very similar fashion. I'm going to look at the denominators and find the common denominator. I'm going to rewrite it real quickly, though, to kind of help myself figure out what that common denominator happens to be. So it'll be 2x over x minus 2 times x plus 2. What I've done is factored the denominator. Equal, and so now we have the same denominator underneath my 4, so x plus 2 times x minus 2. And then minus 3 over x plus 2. So if you see that, what you hopefully recognize is that the common denominator will be x plus 2 and x minus 2. And if you do that, you multiply that, you notice that certain things cancel out. So I'm going to do this a little bit at the same time. So notice with the first term, the denominator will cancel all out with what we're multiplying it by, so you're just left with 2x. Likewise, with the first term on the right side of the equation, notice that the denominator completely cancels out, so you're left with 4. Finally, though, we have the 3, the very last part of term in our equation, and notice how the x plus 2 cancels out, but not the x minus 2, so we'll write it as 3 times x minus 2. Now we have this equation, in which is a lot more manageable. From here, we can solve this linear equation by distributing that negative 3, so negative 3x plus 6. Now we have some like terms right here, so 2x is equal to 4 and 6 make 10 minus 3x. And finally, I'm going to add 3x to both sides, which is 5x is equal to 10. Our first problem now where we do have to divide both sides by the same expression, so x is equal to 2. The very last term, this one I'm going to do it in a slightly different method. I'm going to cross multiply. So notice the denominator of my 2 is 1. So I will simply just cross multiply this equation, which will give me an equivalent equation. Now I have 3x times 1, which is 3x. And I have 2 times the quantity x minus 1. Notice I'm using parentheses because you will have to distribute that. So here I get 3x is equal to 2x minus 2. Which then I'm going to combine or move the like terms to the same side. So I'm going to subtract 2x to both sides, and I get x is equal to -2.
Girls rule the world. Yeah, yeah.